Hello guys, welcome back to my YouTube channel. I'm Prakriti and from CSEI. Today I'm going to present about pump storage plants, which comes under the subject called renewable energy. The contents are introduction to pumped storage plants, principles of operation and components of a pumped storage plant, the advantages of pumped storage plants, disadvantages, geographical considerations for pumped storage, regulatory and environmental factors, and future outlook and applications of pumped storage. Introduction to pumped storage plants. So pumped storage plants are a type of hydroelectric power facility that store energy by pumping water to an upper reservoir during periods of low demand, then releasing it to generate electricity during periods of high demand. This efficient energy storage system helps balance the grid and supports the integration of renewable energy resources. Principle of operation. Pumped storage plants work by using excess electricity to pump water from a lower reservoir to an upper reservoir during periods of low demand. When electricity demand is high, the water is released back down to the lower reservoir, turning turbines to generate electricity. This cyclic process allows for efficient energy storage and transmission, helping to balance the grid and integrate intermittent renewable energy sources. Components of a pumped storage plant. So upper reservoir, lower reservoir, and pumping station and reversible turbine generators. So the upper reservoir is a large body of water situated at a higher elevation, serving as the primary storage for the plant's energy capacity. So lower reservoir is nothing but it is located at a lower elevation, receives the water discharged from the upper reservoir during power generation. So the pumping station uses electricity to pump water from the lower reservoir back up to the upper reservoir, storing energy for later use. So reversible turbine generators can operate in both generating and pumping modes, allowing the plant to switch between energy storage and power generation. Advantages of pumped storage: efficient energy storage, grid stabilization, renewable integration, long lifespan. So efficient energy storage means pumped storage plants can efficiently store large amount of energy of pumping water uphill during off-peak hours and releasing it to generate electricity during periods of high demand. Grid stabilization. The rapid response capabilities of pumped storage can help stabilize the electrical grid by quickly dispatching power to meet fluctuations in supply and demand. Renewable integration. Pumped storage can complement intermittent renewable energy sources like wind and solar by storing excess generation and releasing it when needed. So long lifespan, pump storage facilities have a very long operational lifespan, often over 50 years, providing reliable energy storage for decades. Disadvantages of pumped storage. So high initial cost. So pumped storage plants require significant upfront investments for construction and installation, making them a costly option compared to other energy storage technologies. Environmental impact. The construction of pumped storage facilities can have a significant environmental impact, including land usage, water diversion, and potential dispersion to local ecosystems. Energy losses. The energy conversion process in pumped storage plants results in energy losses, typically around 20 to 30%, reducing the overall efficiency of the system. So these are the disadvantages of pumped storage system. Geographical consideration for pumped storage. The ideal location for a pumped storage plant requires specific geographical features such as two reservoirs at different elevations. Mountainous regions with nearby water resources are often preferred as they provide the necessary height and differential to enable efficient energy storage. Proximity to existing power generation facilities and transmission infrastructure is also crucial to integrate the pumped storage plant into the electrical grid effectively. Site selection must balance topographical, hydrological, and logistical factors for optimal performance. Regulatory and environmental factors. So let's see regulatory oversight. Pumped storage plants are subject to extensive regulatory oversights due to their large-scale infrastructure and potential environmental impact. Permits and approvals are required from various government agencies to ensure compliance with safety, environmental, and land use regulations. Environmental considerations to develop the development of pumped storage plants must carefully consider the potential impact on local ecosystems, water resources, and wildlife habitats. Environmental impact assessments are conducted to mitigate disruptions to sensitive areas and preserve the natural balance. Economic feasibility of pumped storage. Evaluating the economic of pumped storage plants is a complex undertaking that considers several key factors. The high upfront capital cost associated with construction, including dam, reservoir, and turbine installation, can be a significant barrier. However, the long-term operational savings and the revenue potential from energy generations and grid stabilization services must also be weighed. Capital cost, operating cost will be lower than the conventional power plants due to high efficiency and longevity. Reserve revenue streams, energy sales, frequency regulations, backup power, so on, and feasibility factors, electricity prices, energy storage demand, and government incentives, environmental regulations. So, careful financial modeling and cost benefit analysis are essential to determine if a specific pumped storage project can generate sufficient return to justify the significant upfront investment. Innovative financing mechanisms and public-private partnerships may help improve economic feasibilities in some cases. Emerging trends in pump storage technology, advanced turbine designs, new turbine technology with higher efficiencies and variable speed capabilities are enhancing the performance and flexibility of pumped storage plants. Closed loop configuration. So closed loop pump storage systems that recirculate water between upper and lower reservoirs are gaining traction, reducing environmental impacts. Hybrid energy systems, so integrating the pumped storage with other renewable energy sources such as solar and wind, is creating hybrid systems that optimize energy generation and storage. Digitalization and automation, advancements in digital controls and automation are improving the monitoring, optimization, and integration of pumped storage plants into the grid. Future outlook and applications of pumped storage. Grid-scale energy storage. Pumped storage plants are expected to play a crucial role in enabling the integration of large-scale renewable energy sources like wind and solar into power grids, providing long-duration energy storage and grid resilience. So, frequency regulation. The fast ramping capabilities of pumped storage plants make them well suited for frequency regulation, helping to maintain grid stability and power quality as renewable generation fluctuates. Micro grid applications, smaller scale pumped storage systems could be developed uh, in remote or off grid communities, providing reliable long duration energy storage to support local microgrids and increase renewable energy penetration. Thank you.